So here's what we got. We have some kind of polynomial, and what we want to do is we want to figure out what are the zeros of this thing. Now, if we had a graphing calculator, this would be really nice. But for the first six problems of this practice exam, and I don't think I mentioned this, and you'll probably have this when you actually take the test, is you're only going to be allowed to use a scientific calculator. Do you remember that calculator I posted in our class? The one that I keep telling you to use? Well, this one, I gave you two of them actually. I gave you a scientific calculator and a graphing calculator. It would be really nice if we could do, all right, so it says use this calculator from now on. It would be real super nice if we could use a graphing calculator and just plug that into our graphing calculator and solve and look where it crosses zero. The problem is you won't have access to the graphing calculator for this portion of the exam, which will probably be true later on. So I need to show you guys how to approach this thing. Now, if this were something like 4x squared plus 3x plus 4 equals 0, or, I'm sorry, equals y, then we can easily find the zeros using the quadratic equation, using complete the square, or factoring it, if we could, by the way, with something like number x plus number and number x plus number equals 0. And then we could basically set either this is equal to 0, this is equal to 0, and this is equal to 0, so on and so forth. It's what I'm showing my Algebra 2 or my Algebra 1 students. Do you guys recall this thing? Assuming, of course, I could factor something like that. Right. And if I can't factor that, then what I would use is I would use the quadratic equation, or I would use complete the square. But either way, I would be able to do that. Now, in this case, I don't necessarily know how to factor 4x cubed minus 12x squared minus 4x plus 12. So what I'm just going to do, and I'm going to set that equal to 0. I know it says set equal to y, but when I want to find the zeros, I basically set it equal to 0. What I'm going to do is I'm going to just kind of shoot it, or at least do what I can. I don't know how to do everything in this problem, but I'm going to do what I can. All right. I definitely see that each term is divisible by 4. So there's 4 terms, and they're all divisible by the number 4. So I'm going to factor out a 4. Are we cool with that? Okay. And since this is equal to 0, I can divide both sides by 4, and then basically all that really does is it kills the 4. Because 0 divided by 4 is still 0. Alright. What I'm going to try to do, and I think this is where it takes creativity. What I'm going to do is, I'm going to try to pull out an x out of here. Actually, I can pull out 2 x's out of here. Because the reason why I'm going at this, actually, maybe I'll do it first and then I'll show you. Maybe that's a good idea. What I'm going to do is I'm going to pull out 2 x's out of here, so I have x squared times x minus 3. So what I'm saying here is the thing I wrote down on the bottom is the same as what I underlined here. Are we in agreement with that? And then what I'm going to do is I'm going to say, all right, let's see. The reason why I did that is because I have this minus x plus 3 over here. And it kind of looks like this. I wanted to make it kind of look like that. What the problem is, that second one doesn't have an x minus 3, does it? But I guess what I could do, and this is where it may take a little bit of finagling, but I could factor out a negative 1. Would you guys agree with me with that underlined thing is the same as this? Because if I distribute that negative in, I'll still have the negative x, and if I distribute this negative in, I'll have a positive 3. So it's negative x plus 3. Oh, does that make sense to you? Okay. And then over here I have x squared minus x minus 3. Alright. Now this one might be a little bit funky to you. Actually, I don't think it's so much funky, but I can pull out an x minus 3. I can pull out a parenthesis since both of these terms, see I see two terms, both of them have an x minus 3 in there. Like this is kind of like if I have x squared times a minus 1 times a. I can pull out an a out of both of them to make it a times x squared minus 1. Yeah? Good, bad, ugly, what's your thoughts? Okay. Alright. So, let's see. What I'm going to do is I'm going to pull out an x minus 3 out of here. So I have x minus 3 times the parentheses x squared minus 1. That actually tells me what, oh, I'm sorry, this is equal to 0. See the equal to 0 up here? That's what it is. This actually tells me one of my factors. One of my factors is x minus 3. I can further break this down. X squared minus 1, that is simply x minus 1 times x plus 1. If you don't believe me, FOIL it out, and then you'll see that this is the same thing. So I would venture to say that my zeros of this function is when x is equal to positive 3, positive 1, and negative 1. Any questions, comments, concerns, vomits, etc.? Alright, I'm going to jump over to the graphing calculator and I'll prove it to you. Let's go graphing, and this is the actual calculator that you guys are going to be using on your test. So you might want to get to know it. Let me plug in what I want. Let's see, how do I use this again? Okay, I'll go 4x cubed, so that would be to the third power, plus 12x squared, plus, oops, not plus, backspace, minus 4x plus 12. Alright, cool. And then let me take a look at the graph of that. Okay, wait, let's see. No, I don't, I don't know. I guess maybe you have to ask the teacher. Wait, let's see. 4x cubed minus 12x squared minus 4x plus 12. Is that the right one? Oh, oops. I put in the equation wrong. I put a plus instead of a minus. All right, let's graph that. There we go. Okay. I don't know. I bet you will have the computers provided, and the computer has a built-in calculator, or the test has a built-in calculator, which is exactly this one. So I want you to get used to it, because you guys can see this. Now, you won't be able to use the graphing calculator on that particular problem. I'm using the graphing calculator to show you what the numbers are. It crosses at -1, +1, and 3, which is exactly our answers. And you can see that this is actually looks like the regular cubic function that you've grown to learn and love. We cool with this? Awesome. Let me stop.